Hello, my name is Yasmin Ali. I am an undergrad growth facilities assistant at the University of Toronto in Mississauga, and this is the Precision and Analytical Balance instructional video. We will cover two main parts in this video. First, the types of scales at the RGH, and then how to measure and handle. When looking at the differences in using the balance, it's important to understand the different metrics for precision and consistent accuracy. In this video, when referring to the maximum weight readability, we are describing the smallest weight difference the scale can detect. For example, if the maximum weight readability is 0.01 gram and you weigh two objects on the scale, one weighing 10.00 gram and another weighing 10.01 gram, the balance will show the difference. The linearity deviation refers to how accurately the balance measures weight across its range, or the range of different weights the balance might be off by. For example, if the linearity deviation equals to 0.001 gram and you weigh 100 grams, the scale could display a reading between 99.999 grams to 100.001 gram. The tolerance refers to the acceptable variation in a measurement. As no scale is perfect, this accounts for the expected error margin based on the weight. For example, if a scale is calibrated with a tolerance of 1%, for samples that weigh less than 0.1 gram, this means the measurement can vary by plus or minus 1% of the actual weight and still be considered accurate. Suppose you want to weight a sample of 0.05 grams, which is less than 0.1 gram. You can calculate 1% of 0.05 grams by multiplying the values. To get what the weight can fluctuate by within the acceptable range of 0.0495 grams to 0.0505 grams. As long as the measured weight falls within this range, it can be considered accurate based on the scale's calibration settings for a 0.05 gram reading. The precision balance can weigh samples at a maximum of 12.2 kilograms to 12,200 grams. The model has a maximum weight readability, again, the smallest increment of weight the scale can display or detect, of 0.01 grams. The scale's linearity deviation, representing its ability to maintain accuracy across the entire weighing range from minimum to maximum, has the deviation of 0.006 grams. As the weight decreases, the tolerance percentage increases, meaning it's less precise measurements due to a wider acceptability range. For example, for the precision balance, the minimum weight to have tolerance of 0.1% is 8.2 grams. This means that for weight 8.2 grams or higher, the scale maintains an accuracy within a 0.1% tolerance. If the weight is below 8.2 grams, the accuracy may decrease, leading to higher measurement uncertainty. The analytical balance can weigh samples at a maximum capacity of 120 grams. The model has a maximum weight readability of 0.01 milligram or 0.00001 gram. The scale has linearity deviation equal to 0.06 milligrams or 0.00006 grams. As noted by the minimum weight tolerance listed on screen, the weight decreases as the tolerance percentage increases, meaning it's less precise measurements due to a wider acceptability range. This is because accuracy at very light weights are more heavily impacted by smaller fluctuations, like movement. Between the scales, the precision balance is better suited for weighing larger sized and heavier samples due to its high maximum capacity of 12.2 kilograms, and better suited for general weighing tasks because of its versatility and ability to handle a wide range of sample weights while maintaining moderate precision. The analytical balance is better suited for smaller, more precise measurements with a lower maximum capacity of 120 grams. Additionally, the balance has better accuracy due to its higher readability, again, which is the smallest weight increment the scale can display, as well as drift shields as imaged, which aid in maintaining accuracy from external variables in the RGH for sensitive environments and sample measurements. The materials needed include hand gloves, a weighing vessel, a dish, weighing boat or pan, tweezers for weights if needed, and a scupula. For remote control and data transfer, refer to the manual on the RGH instrument page or the UTM Bookit Lab website. To begin weighing with the precision balance, press the power button without any weight vessels, then click the green button in the top corner, undo the levers in the back, and adjust with the side controls according to the screen instructions. Place the weight vessel and click the tar button in the middle. Ensure the scale is clean to eliminate error from unknown weight sources. Add your sample and wait till the values reach stability. Then click Sample ID in the top corner and type characters and/or numbers to name your measurement. In the bottom corner, you may click the green Start and Add button to measure more samples in one dataset. Once finished, press Complete. For the analytical balance, turn on without the weighing vessel on the scale. Then follow the same calibration steps as the precision balance. Next, open the drift doors to insert the weighing vessel. Make sure to close the door when tarring and weighing to minimize the noise and external factors that can influence the scale, especially for smaller samples. For serial measurements, press Start and add sample, wait for the values to stabilize, and repeat the sample ID steps. Then press the Add button and add the next sample amount. Again, wait for the values to stabilize and repeat the sample ID steps. Once finished with the dataset, press Complete. To clean both scales, remove the weighing vessel and brush away any contaminants left over.